Thank you. I'm impressed by the number of people in this room. Thank you for joining me. Thank you for being here. I have a lot to talk about, so let's dive in directly. Who am I? I'm Frank Delporte. This is a home match for me. I live here in Belgium, a bit far away from here, but Belgium is not that big. You can find me on Twitter. I do a lot of tweeting about Java, especially Java on the Raspberry Pi. I blog on my own website. I also blog on pi4j.io. Who knows pi4j.io? No, that's not enough hands. If there's one link you take home with you today, it's pi4j.io, the website for the friends of OpenJDK, and I can imagine we all are friends of OpenJDK. All the links of this talk you can find on my own blog, webtechie.be, so actually you should remember 2 links if you go home. I graduated in 1994, actually as a movie video editor. This is the first time I'm in a movie theater with my work, so it's a bit ironic that it's with a presentation about software. But that means I have been through this whole evolution of video tapes, going digital, going to websites. I am also part of the generation that created that annoying skip intro flash animations. Yes, that was me, part of that team. But since more than 10 years, I've been working mainly with Java. 2 Belgian companies I worked for, Televic, creating these screens that you can find in trains, metros, trams. And we were using Java both on the train as a service and both on the wayside to bring real-time passenger information to the trains. And then I joined the startup, creating this worker robot. And also there we use Java at the back end. So Java is dead? No, it's definitely not dead. Even startups choose Java, not only the hipster ones with Node and stuff like that. No, we were using Java to control firmware for these updates and have some stuff going on there. Just before the summer, I joined Azul as a technical writer, so I'm part of the docs team. The docs that no one wants to read, but you want to read them because I'm part of it now. And we built with Azul 2 versions of OpenJDK. We have Zulu, which is a version of OpenJDK which runs on all platforms. And why I want to point it out here is it also runs on the Raspberry Pi. Even the very first generations of the Raspberry Pi, you will find an OpenJDK Zulu version for these boards. Azul also creates Platform Prime, aiming at high loads, high performance, no code change, just a replacement of your GDK. But this is all the sales talk I'm going to do. If you want to learn more about Azul, we are one of the sponsors, so you can find the booth in the conference area. Now, I've been programming since the 80s. I'm old, so I started with the Commodore 64. I think there are others in the room who have had this same experience. This is so long ago that there doesn't even exist a picture of me on my own computer. It's only a friend of me on the computer, and I'm the nerd on the right side with the glasses. So I think, yeah, the nerd term was invented for me, but that's a quality trademark. We agree all? And in my opinion, that Commodore 64 was better than the modern computer I'm using at this moment. And for one specific reason. And that reason is the backside of that computer. You have all these connections there, and you were able to connect hardware to that computer. So what I could do as a 14-year-old boy, I had my Lego train controlled with my Commodore 64, and I had magnetic switches along the side of my track, so my computer even knew where the train was because I was abusing the joystick ports for that. And that's something I could do already many years ago with my Commodore 64, so I could control the real physical world with some programming. And now the same experience, I found that back with the Raspberry Pi. Now I hope you all know what a Raspberry Pi is, but they look very big on that screen. But actually this is the small one. This is the Pi0, so that's the 3rd one. And it's a 15 euro PC, the second version is a 15 euro PC. This is a full Linux PC, it runs Java. It runs JavaFX. Of course, it's not as fast as any other PC. But the idea of the Raspberry Pi Foundation was, let us bring a computer to the world for everyone. Everyone can buy a computer. The very first versions of these Raspberry Pis even didn't have a digital connection for a screen, but an analog connection, so you could connect it to any television. So you didn't need to buy a monitor, you could connect it to your television. Most people have a television, now they could also connect a computer. They did some amazing things with this very small one. This processor is actually a two-layer thing with memory and the processor on top of it to fit it in this very small form factor. If you want to build a product that contains a PC, but you don't want to develop the hardware for that, you have the compute module. The idea there is, you see there is no USB, no network connection, no monitor connection. You have to design a baseboard for it. You can buy one, there are several ones available on the market, but you can create your own one specifically for the device that you are creating and adding the connectors that you need. So this is the range of Raspberry Pi boards. I'm using most the B-type because it has a lot of connections. You can add two screens. So what is this Raspberry Pi? It's a single board computer. It's a full Linux computer. You can both run a server and a desktop version on it. There are different operating systems available, 32 and 64-bit, only for the latest generations of the Raspberry Pi. You have the operating system provided by the Raspberry Pi Foundation, that's Raspberry Pi OS, but you also have media servers, a NAS storage device, retro games, whatever you can imagine. There is an operating system, Kali Linux, if you want to experiment with security and hacking. I should not promote hacking probably, but there are operating systems for that. They make 400,000 Raspberry Pis a month, but you cannot buy them because that's not enough. We all suffer from the chip shortage in everything, in cars, in dishwashers, but also in computers, of course. Who has a Raspberry Pi? Wow, yes. Who is using it? You have a piece of gold, use it. It's very hard to find them. If you really want a new one, go to rpilocator.com. If you're lucky enough, they will show you where you can buy an official one at the official price. But you have to be fast, and most of the times, most shops, official shops, only sell you one piece at a time. This website, so you will definitely find them at multiple times the normal price. Be careful with that. The official price is with the official dealers. Now, I find this a very amazing product. So the Raspberry Pi 4 has two connections for screens. We can have dual connectors, dual screens, 4K. So when I was working on these examples in a book, I was actually using a 4K display. I had two Visual Studios, I had Arduino, I had a terminal, I had a File Explorer, so everything on a Raspberry Pi 4. Of course, I was also using another PC for the more faster things, but it is a PC. It is a really powerful device. Now, a few years ago, they released the Raspberry Pi 400, and that's actually the Pi 4, and they rearranged the components a bit in a long format, and they put it in a keyboard. So you just connect a monitor, a power supply, and a mouse, and you can get started. This is about 100 euros that they ask for this. Now, does this ring a bell? The same connector on the, well, it's not the same connector, but you have the connector on the back side where you can connect a lot of different things. So it's really going back into my roots, and this is an amazing device. For me, it's a bit painful to say, but there's 37 years between them. If you look at the price, if you recalculate the price of the Commodore 64 to the current pricing, it would be about 1,500 euros. Now you have this, a lot more power, a lot more fun, a lot more possibilities for under 100 euros. And the most important part of the Raspberry Pi, and actually that's a fun story, there are these pins, and we will come back to these later, where you can connect devices. Actually, they were not going to do that in the first edition of the Raspberry Pi. It was only by coincidence, we have some spare space on this little board, let's add some pins. Now, these have proven to be the really added value of the Raspberry Pi. You can do fun things with it. I think this guy has the best job in the world. He works for Oracle, but he creates fun things for Oracle to illustrate the power of any kind of software. He has created this. This is 1024 Raspberry Pis in one rack. If you have a good idea what you can do with it, just contact him and you can run it on his rack. Now, he built this just before Corona, and like a lot of things, this got abandoned. It ended up in a warehouse. He dug it up a few months ago, moved it to his garage, restored it, and it will be at Java 1 next week. He even built a small one, and he has some crazy idea. He sent me this picture without any information, so I have no idea what he's going to do, but he has some funny ideas. Now, another very fun project by Ivan Kuleshov from JetBrains. So this compute module, the idea is you build around the compute module whatever you want. He created this blade, and you can put a lot of them in a small box or in a big box, and you have, again, your clusters. You can do Kubernetes stuff or whatever you want to do with a lot of Raspberry Pis. Just fun projects. Keep an eye on them. There are many, 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 many more happening inside this Raspberry Pi world. Now, why Java? Good question. Raspberry Pi, the Pi stands for the number pi, but it also is because Python was initially the idea. Let's put Python on this board and let people learn to program with Python. But actually, so it's Linux. And Java runs on everything, so of course Java also runs on the Raspberry Pi. Why did I start experimenting with it? Because Java is my language. I have been using it for over 10 years, so I wanted to learn how to control electronics. I didn't want to learn a new language. I wanted to experiment with this component. So putting text on such a small display, or controlling a LED matrix, or reading a sensor value and showing it in a graph. So that's the thing I wanted to learn. What I learned recently is that Java is even very energy efficient, and that becomes very important nowadays with all these ecological problems. If you compare a similar function in different languages, this is not written by a Java guy, by the way. This is a really official research project. Then you see that Java uses twice the amount of energy for a similar function as in C, while Python has a bit a higher number. So if you're looking into an energy efficient device, then C, Java, they are really comparable at that matter. JavaFX, who uses JavaFX? Still a few hands. JavaFX seems to be the forgotten framework in Java world. Creating applications is done with JavaScript, things I hate, because they keep changing and keep new versions and new frameworks, and this framework is better. JavaFX has been very stable in many years. There is a big Gluon, which is for main part Belgian, done by Belgian developers, is one of the main maintainers of JavaFX, but you have this whole community who create amazing libraries to do fun stuff with JavaFX, like if you need a word-like menu, if you want to create a dashboard, if you want to start game development, you can do that with Java and FXGL. So there are a lot of libraries there. And it's not only libraries, of course, in JavaFX. We have this whole community creating libraries and tools and helping each other. And I was looking at a slide, an image I could show you here, but I want to go back to Pi4J. It was part of my introduction. It's so this, the Friends of OpenJDK. It is a website started by Azul, but Azul is only one of the partners at this moment. There's a whole board of companies behind it. And everyone who wants to contribute content to Pi4J related to Java, to the JVM, everything related to that can contribute. We now have over 150 contributors to this website. I think a lot of them are even here at Devox. Every day you have a new article. Every release of Java is available here and documented here. And I'm one of the contributors, of course. If you look at Raspberry Pi or Raspberry, you will find more than 50 blog posts related to what you can do with Java and the Raspberry Pi, that combination. And if you look at only these examples, Vaden, they're also one of the sponsors in the exposition hall. Jibang, that was a short session I did yesterday. SDKman, if you want to switch between Java versions. I contributed to SDKman to make sure that it also runs on the Raspberry Pi. Pi4J, JavaFX, all these tools that you know from your daily use, you can also use them on the Raspberry Pi. Or if you didn't use them, use a Raspberry Pi to experiment with them. This was part of the keynote yesterday by Venkat. We have this high evolution now in Java. We have a new release every 6 months. If you want to experiment with a new release, with new features, go to a Raspberry Pi and try it out. Because every new release also brings memory improvements, speed improvements. So all this has an impact on how your application will behave on this small device. And as I said in the beginning, I didn't want to learn a new language. I wanted to experiment with electronics, and this was what this whole talk is about. Tom Coles will have a very nice session tomorrow about this. Focus on one thing. Don't get caught in a rabbit hole and trying out too much new things at the same time. So I knew Java a bit. If you were in the session before me here in this room, there were some very hard questions. I know now that I'm not the best Java developer, but I am a Java developer, and I wanted to experiment with new things, so I focused on the electronics. So this whole story started 3 years ago. Can we have some music? This is my son. He has a drum boot because this makes a lot of noise. So I added a Raspberry Pi, I added an Arduino, I added a touch screen. He can control all these lights. And the Arduino is connected to some LED strips so that you have some nice light effects. And because everything is controlled with Java, of course there is an API. And with the API we can trigger the red alert. Please stop and come down. For instance, dinner is... He drums upstairs, we live downstairs, so if you're downstairs and shouting it doesn't work. This works. So I wanted to create this. I have never done JavaFX on a Raspberry Pi, never controlled electronics, so I had a lot to learn. By the way, I had to add a slide. I can only show you the video with the permission of my son if you subscribe to his YouTube channel. You will make a 12-year-old boy very happy. So how to build this with Java? That was my question. So in the next 6 months, this was the 4th member of our family living on the kitchen table, and every night I was experimenting with another component. I wanted to use this type of component that you see in a clock. How do you control it? And eventually I use it as an example of how you can convert a number to bits, because you have 8 segments in this type of display, so each bit becomes one LED light to form a number. And after 6 months, I had a lot of materials, I had a lot of documentation, and eventually it ended up in a book. So if you want to learn more about this subject, I can recommend you this book. Of course, it's mine. It is in paper available at Elector. I have a digital version via LeanPub, and the digital version, of course, I can keep updating that one. Now, during this journey, I met Pi4J, another amazing library, Pi4J.com. I followed a course about storytelling. You're allowed to have one slide with too many texts. This is the one. So Pi4J is a friendly, object-oriented API, provides you with libraries for Java programmers. Java is very important in here, the way you work with Java, to access the full capabilities of the Raspberry Pi platform. So you don't need to care about how does this electronic work, how do I control this electronic. You focus on the business logic. Even if it's a fun game project or a pet project that you are creating, you focus on the logic. How does it work? You have a Java application, of course. You have a library that will help you. Inside this library, this is a native library, GNI, and it will access these pins for you and make sure that you can interact with them. Now, this project was already here in Devoxx. In 2014, Robert Savage, who created this project, was here, presented it. So he started with this project in 2012. While writing this book, I got into contact with him. I joined the project. It's an open source project. I joined it as a documenter, so I created a new website. And together we worked on a new edition of this library for several reasons: to make it easier to maintain, simpler to test. Also, we needed to replace the native library because that one, wiring Pi, was deprecated. It was also using a very strange numbering to identify the pins, so that caused a lot of confusion. In the second edition, this is solved. We have even 2 native libraries that we can support, and we can add more because it's a very modular, yes, it's modular based. We can have different implementations. And from there on, we decided this will also be for Java 11 and higher. About the pin numbering, if you want to find out, so there are 40 pins on most of these Raspberry Pis. If you want to find out what these pins are exactly are and what you can do with it and find the right numbering, there is a great website, pinout.xyz, which will help you. But I have a sneak preview for you today. Since last week, this is live. If you all visit it now right at the same time, it will crash because I'm the only one who tested it before. The idea is that we have a Java library again within the Pi4J project, which contains all the information about the available Raspberry Pi boards, but we also have an application running on top of that. So it's a Vaadin Spring application, listing all the boards, for all the boards showing an overview of the pins. Because it's Java and Spring, of course, we have an API, we have Swagger, we have JSON output, and it is hosted on a Raspberry Pi, of course. So this is running in Czech, in Prague. This company was so kind to give us a free Raspberry Pi that is running this application. Now, this is not only the only real-life example. A few other examples that are using Pi4J. This is a medical sorting machine to distribute medicines in a hospital. And the second thing is receiving these medicines. And as a pharmacist in the hospital, you select a patient. It shows you have to take 5 of these pills. And it shows them in green. It's not that clear on the slide, but the middle drawer is green. If you put your hand in the wrong side of the box, it will turn red. It will not slap, it will turn red. But there is a Raspberry Pi inside this drawer to handle that. And on the right side, I'll present you Didier. Didier is a street robot. If you open it, it has a lot of wires and Raspberry Pis, and it has a LED matrix. It creates sound. It's part of a street theater act. There are a lot more. There are more examples on the Pi4J website. Please take a look. So this Pi4J website is a new website that we created together with version 2 of the library. Just like Pi4J.io wants to be the website collecting all information about Java, Pi4J wants to be the website that collects all information about Java on the Raspberry Pi. So you will also find how you can install a Java version on an older Raspberry Pi, how you can install JavaFX, how you can run JavaFX in kiosk mode, and all that kind of information you will find here. And also a lot of examples, of course. The minimal example is the hello world of electronic programming. I have the same setup with me. So it's just using a LED and some wires, and you can get started. I think there's a few cents of components on this board, so that's very minimal. So how do you do this? You need a few dependencies. By the way, we use Maven most of the time inside the Pi4J project. There's also an example with Gradle if you prefer that. You need a context. So you see we are just working in plain Java code. We have a Pi4J context, and within that context, we can create a configuration for a LED. So if we want to configure a LED, we need to know the number, pin number 22. This is actual physical pin is number 15, so that's how you find it on the board. Some other parameters, and then we create a LED with this configuration. So that means that this LED, this LED, is now a Java object, and we can handle it as a Java object. So turning it on and off, low and high, that's how we now toggle this LED. Now this example application also contains a button. The idea is if you press the button, the LED starts flashing a bit faster, and after 5 times the program stops. And that's what you see here. By the way, this fancy cooler thing is an option. I'm an influencer in Raspberry Pi, so that's why I got this for free. It's the only thing I ever got for free, by the way. So you see, it's not rocket science. It's just an illustration of. So this minimal example is one of the examples you will find on the Pi4J website. You can just grab the sources from GitHub and you have a finished project. So you see how this works. There's a lot of commands in the code to help you and illustrate how this all works. And it is a starting point. But for me, the first time blinking a LED with a Java program from a Raspberry Pi was an aha-erlebnis, as they call it. So let's just take this a bit further. So we have now a blinking LED, we know how this works, we can do a bit more. This is something we're gonna build in the remaining half of my session. We have a board sending a lot of data, and we have a dashboard, and we want to show what this other board is sending. That's the end goal of what we want to achieve. Now we're going to use messaging. A lot of messaging is used in modern applications. We're going to do the same. What is messaging? If you don't know, we have one application or device sending data in any format that you agree on. On the other side, we can have an application that sends data or receives it, or a combination of both. So it says to the broker in the middle, I want to receive all the messages which are sent to post box X, and it will get them. Mosquito is one of those post boxes, message handlers, how you want to call it. And Mosquito is also available on the Raspberry Pi. So if you have a spare Raspberry Pi that you can use as the central point to gather all your data or your messages, you can do so. So installing Mosquito on Raspberry Pi is actually a single line for Mosquito and the Mosquito clients. Once you have done that and you open 2 new terminals, you can have these test programs that you can use. You have Mosquito publish, something to topic, and then you define the post box, and there your message. And on the other, in the middle, you have the subscriber, which is also a test program, just to see what is happening in this broker and which messages are received there. As part of my experiments, I have created this little JavaFX application, which does the same. So it also subscribes to the same broker, get the messages, and can send messages. By the way, all the examples which are part of my book are in one single big project on GitHub. So if you are looking for sources for projects to start experimenting, is Delporte Java on Raspberry Pi. So they are organized according to the chapters. So I advise you to buy the book and put it next to it. But here you will find all the sources for free. I was asked by HiveMQ to create an example application. So actually, instead of Mosquito, I wrote 3 articles using HiveMQ. If you don't know them, they are a Java-based MQTT broker, so MQTT compatible Mosquito, but created in Java. They also provide hosted solutions. So you have an open source version, you have a licensed version, and you have a cloud version. And why is this cloud version so fun for us? Because you can have 100 clients for free. So if you want to start experimenting with this messaging, you don't want to use Raspberry Pi to be your post box, or you want to connect different locations and you don't have a public IP, you can use HiveMQ for free. Just go to hivemq.com and you will be able to register and get your broker for free. So you will see that once you're logged in, you have a cluster In this case, it's a very simple cluster which can handle 100 clients. You can define your own credentials. So if you want to have different connections, secure connections, you can do that. And the fun thing is that they also have a WebSocket web test page. So if you go to this test page and you log in as a client to your cluster, you will see all the messages in the browser. So if you have different Arduinos, Raspberry Pis, whatever, sending data to this broker, you will see these messages also appear in your browser. So that's a way to validate that this whole flow is working okay. I'm going to use a CrowPi. I have them with me also. A fun story, I was giving this presentation as a test to my colleagues in Prague 2 weeks ago, and I didn't dare to take this with me on the plane. There's this kind of timer that they use in every movie if they have a bomb. So, as I live in Belgium, I could safely bring it here. What is the idea of the CrowPi? It's about 200 euros without the Raspberry Pi. Is that you plug in a Raspberry Pi and it is wired to all these sensors and devices. So if your program doesn't work as expected, it's probably because you messed up the code, because the wiring is fixed. So that's one thing you don't need to worry about. Now you will find also a lot of information about this on the Pi4J website, because the FHNW University of Switzerland, they use CrowPi, they use Java, they use JavaFX, they use electronics in their study program. And one of the study projects last year was create example applications for all these components. So again, this is a GitHub project freely to use within the Pi4J project. And you will see that they have applications for the button, for the buzzer, for everything that's inside the CrowPi. And this is the output. I have one here, so this is the other one. There's one problem with the CrowPi. They forgot to add a connection for the second screen, so I cannot add it to the big screen. So this is the second edition of the CrowPi with the bigger screen, and ta-da! You can take out the keyboard, and then you have this. Huh? So that's a bit the idea. And it can play sound. This is also done with Java. So it's again a very basic example, controlling a component with Java. It goes on for a bit. Voilà, thank you. So that's one of the example applications that is available here. So there are more, like for the LCD display, the light matrix. All these applications are available there. And what I did is I used these examples created by these students. I'm a lazy programmer, so I just took what existed and I used that for the -q examples that we're going to use. So the whole project that we will now see is, again, available on GitHub, -q examples. So what we're going to do is we're going to connect one of these devices to the cloud and send data. That's what we want to achieve in the first step. So again, we need some dependencies. Pi4J is there, of course. What we also need is a library to connect with MQTT to this broker. I'm using, in this example, the -q library. They have their own library. I think it's based on top of Pi4J. That's another known one for MQTT messaging. But they have a very nice way to define the connection, and that's why I like it. So what you need is your server address, a username, and a password. And then you define a client. So the client is the MQTT client. Few lines of code. You identify your device that's unique. You have the host address, a port. There is a default secure config that's available there that will handle all the security stuff and the TLS so that you have a secure connection with your broker. And then you need to connect. I didn't use any reconnect here, but that's also part of the library. So you can automatically reconnect if the connection gets lost for one or another reason. And if you want to publish something, it's just publish with. We publish to a certain topic. And we give the payload. So the payload is any kind of message that you want to exchanged to this broker. I'm using JSON, can be XML, it can be plain strings, whatever you want to exchange. It expects strings, so you can put everything you want there. Exactly once is how many times the system should retry if something fails in the transmission. But explaining the whole MQTT thing is not the goal of this session. So we're going to use a digital input. So we want to see something from the device. In this case, it's the motion sensor. So there is a little motion sensor here. It's the white thing inside there. So if something moves above the CrowPy, we want to know about it. And again, because we're using Pi4J, this is just Java code. We create an input with a certain config for a certain address, the address being the PIN number where the device is connected to, and some default values that can be used there. And the students did a very nice approach. They added a system of events and states, so you can use the state. So if movement is detected, we want to emit this message. If it's standing still again, we want to emit another message. Now, if we run this, so you see it's with the CrowPy 1 on the top, and you have the output of the application. Too many output, but for testing, this is of course nice. So everything you do with the device, it's not only the motion, it's also noise, it's tilt. Every second, it sends the temperature, humidity, using all the sensors which are available in this device. That's why it's a nice testing tool, because you have all these sensors available. And this is this web page where you can see that these messages are really flowing through the system. By the way, this whole messaging approach is most of the time overkill for a home automation project, but of course, as developers, that's what we always want to achieve. Now let's focus on the other side. We want to show what we get from these sensors. Gerrit Grunwald, known on Twitter as Han Solo, he created this amazing JavaFX library, TilesFX. It's always a good idea to add your own picture to your demo application, so Gerrit is on the right side. This is a very nice JavaFX library where you have all these different tiles available. He created a glue-on monitor for his kid who has a medical thing. So he has this all these different tiles and dashboards that you can create with this application. And that's what we're going to use. So we're going to use a tile. A tile is part of this TilesFX library. And we have a sensor switch. So the sensor switch is on top in the middle. That's the sensor we want, the switch we want to use to show if the device is moving or not moving. And we just define the tile as a skin type switch. We give it a width and a height. And next one. And we connect it to a message. So we have these messages coming in because we are using exactly the same client and client connection code as in the other application. So we have the same way of receiving data. And we set the active state of this sensor based on the true or false value of the motion sensor. A little trick for JavaFX. JavaFX is running in its own thread. So actions happening from another thread need to be executed with its platform run later to make sure that you have no thread issues. And yeah, we get a lot of other data. We have seen that in the first video. So we can also link the temperature, the humidity, the distance. So all different types of tiles are used to visualize this data. Now, if you combine all this, then we end up with such a thing. So again, on the right side is the same video as we had before. The logging you now see is from the receiver side. And whenever something is touched or moved, or you have all these things happening over there. Okay. So This is a very, very, very fast introduction to Pi4J. And why is it fast? Because there's so much you can do with this. As soon as you start collecting some components, if you want to start doing this, the CrowPi is only one option. For 20, 30, 40 euros, you can find on eBay a very good kit with all kinds of components, like a few LEDs, a few buttons, a distance sensor. So all these are the components you need to get started with this. So I invite you to visit Pi4J. So Pi4J is the site with everything related to OpenJDK. Visit Pi4J if you want to get into the knowledge of what can I do with electronics on the Raspberry Pi, what can I do with JavaFX, with other tools on the Raspberry Pi. And definitely experiment, fail. I have done a lot of experiments. I didn't destroy any Raspberry Pi. I did destroy a few LEDs and other things, but the Raspberry Pi is actually a very good thing and very error-friendly, let's call it like that. I even put too many voltage on them, it survives. So don't be afraid to experiment and try different things. And definitely have fun, because if you see the impact of your Java code and how this interacts with motors, building robots, whatever, reading sensor data, then you get to start with having a lot of fun with all these things. If you want to learn more, this is a great book, and you can find me on Twitter for any questions, or maybe you have questions now. Thank you. Yes? Yeah.
My usual problem with using it as robotics part is usually like transitioning to production. So you're using all of this to play with it, try out stuff and all the sensors, that's very nice, but are you going to use it in a real environment? Like eventually you need to transition and then you need to go to another platform. So you need to read it, develop everything again. So I'm always missing the link.
Yeah, so the question is, should I use this in production? Pi4J, it's a pet project for us. So it's an open source project. I'm not going to guarantee that this works perfectly in production, but the Raspberry Pi itself is a proven product. There are washing machines with it. There are a lot of business applications where they use Raspberry Pis. So definitely the compute module, for instance. If you see that they build 400,000 Raspberry Pis per month, only a very limited amount of them goes to the public websites. All the others are already reserved for professional use. So should you use the Raspberry Pi in production? Definitely. There are a lot doing that. Pi4J, I invite you to join the project if you have tested it in a lot of projects and it has proven. One of the contributors of the Pi4J project has done it with the medicine system. So it can be used, yes. But it's a thin line between, is this, is it a pet project and will it stay a pet project, or will it become an official product? But a startup I know started with a Raspberry Pi and indeed then moved on to, for instance, Jetson, if it's for artificial intelligence, stuff like that. But there are different paths that you can take there. Yeah, agree.
But you're saying it's used maybe in appliances and things like
It is used in appliances.
What about mission critical stuff, like example, self-driving car or something like that?
No. I don't think, no. Or redundant, or, yeah. So, but by the way, I don't have shares in Raspberry Pi, so I'm not, I don't have to, I don't have to sell them.
Yeah, one of the fun things about like an Arduino is once it has power, it does its thing. It's a loop and like sends data. I have a traffic light that I control with an Arduino, and I'm inspired to use a Raspberry Pi and maybe do some network stuff. How do you, or is there a way to get this always on once it gets power easily done? Because it's Linux, then you need to write a service.
You need to write it as a service, indeed.
I've done it, it's a hassle. Is there an easier way?
I use it as a service, and I don't have real issues with that. The drum boot of my son, he just plugs off the power if he's done and turns it on again. The issue there is the SD card. used by the Raspberry Pi. So the SD cards can get corrupted pretty fast. Solution is switch to an USB drive, flash drive, or make the SD card read-only. That's also an option. You can do that. And then your memory that you need is, or the files that you need to read, like log files, are read in volatile disks. So if you unpower the device, it's gone. Which can be an issue if you need the log files.
Or you can just send it somewhere to a log
Or send it somewhere else, yeah. But making an SD card read-only is one of the solutions.
And then you could probably flash the SD card again on your PC if you need to update the software. So
I have a lot of Ansible scripts to start over again, because that's what you get when you experiment. It gets broken very fast. Yeah, you need an easy way to recover. Ansible is a great tool there. Yeah, yeah, yeah.
The new Pis, you can also run your OS from the local network.
Yeah.
You can network boot it.
I think that's what they do with a big 1024 cluster. Yeah. You put your operating system on a server.
you do not want to flash 1024 SD cards.
Yeah, the last weeks he was connecting fans per 4 boards or something like that. So that was days and days. I have so many fans installed. So yeah, you don't want to do the SD cards regularly.
But if you want to add internet to your current product, you could also use an ESP or something. That's basically Arduino with a Wi-Fi chip.
Yeah. Yeah, but there's also, you don't have to use the Raspberry Pi for everything. Eh?
No, I have one laying around.
Yeah.
I don't know what to do with it.
You have to get it out, you know.
Laying around, I don't know what to do.
You could plug your Arduino into the Raspberry Pi and send it the commands over serial.
Yeah, that's what I do in the drum boot of my sons. I don't use messaging there. So you have the touchscreen device, it's sending a serial command to the Arduino, because Arduino is much better in controlling LED strips. Or reading temperature, or that kind of things. Yeah, yeah. And the problem there is not the Java, not Pi4J. It's really that the Linux is not a real-time operating system. You're not sure of the timings.
Yeah, there was the next question, like how real-time is all of this? Because you need to, like, if you press the button, stuff needs to happen, and you need to do the exact
That's fine.
PW and
Once you want to use pulse width modulation or something for your servos, you can't do it without an external component.
Yeah. I see we have a makerspace in the making here. Next time in DevOps, you'll have an experimentation lab. Okay, if there are any more questions, I will be at the Azul booth in the afternoon. Thanks a lot.